Lesson 3.6, Nonlinear Models. What are we going to learn? We're going to learn how to classify scatterplots. Then we're going to use those scatterplots to find a model for the data. And then we're going to try to find the model that best fits the data. And we're going to also talk about how to find exponential and logistic models for data. Let's start here. Let's figure out how to classify the scatterplots. In this example, we want to decide whether each set of data would be best modeled by a linear model, y equals mx plus b, an exponential model, y equals ab to the x, or a log model, a plus bx and natural log of x. We're going to use a lot of calculator in this lesson. First thing we do is we have to type in all this data. We're going to go to stat right here, and then we're going to go to edit. And we still have to type in all this data. I do that off camera. It's all typed in now. You have to put all the x's for L1, and then you have to put all the y's for L2. So I have to go back and put all the y's. There's my data. The next, we want a graph in the stat plot. So if you hit y equals, you generally have a graph here. We don't want the graph. We don't have an equation yet. We want a stat plot. So we have to go stat plot. And the way you do that is press second and then stat plot. Pick any one of these you want. And we got to turn it on, first of all. And then what type of data do we want? We want a scatter plot, so we're going to leave it the way it is. You can also get a line data. You could get a table. You could get a box and whisker, with frequency. We're going to leave it as a scatter plot. L1, L2, X and Y. I did put X for L1 and Y for L2. And this is the marker. Then I'm going to hit graph. And you can kind of see the data there. I can actually make the data a little better. If you go to window, your X, meaning you want that to be the lowest X value, like maybe 0. 2 works, but 0 is probably a little better. You can see it. X max will be the highest X value. So in this case, 9.5. Let's put 10 or leave it. Scale is how you want to count. We're just going to count by 1. We'll generally leave it at 1. Y min. Lowest Y I see is 1, so 0 to 10 probably works again. Something to that effect. Again, Y max I think is 10. We can leave it there. Scale and res. Res is like resolution. I never changed these two. Hit graph, and you can see it a little clearer. Now look at this data. What does it look like? Does it look like a line? Kind of, but I would say it looks actually more like a exponential graph. For A, I'm just going to do a little picture of what it looks like. It kind of looks like this. I would say that's an exponential graph. It's y equals a b to the x. That's the first one. Again, we'll talk about how to actually make a model for this data in a second, but first you type down the data. How does that work? How does it look like? How do you work with this calculator? Next, we're going to do the same thing for B. We're going to type in all the data, and I'll do that. I'm going to go back to stat. Go back to edit. Here's the important data here. How do I clear this? Well, you go to L1, you put clear. You press enter, and it clears all the data. A lot of people go, you could delete an entry if you want. That works. You do a lot. A lot of people accidentally delete the line and then you just lose it. Like, where did L2 go? Well, it's gone until you get it back. How do you get it back? You're going to go back out. You're going to go back to stats, and we're going to go down here to setup editor. That's going to fix your editor. Setup editor, press enter, and then if you go back to stat and then edit, that's where you type it in, you see L2's back. So we just want to clear L2. And we're going to type in all this data for L2. Here we go, type it all in. But when I was doing that, I realized that the X values didn't change. Didn't need to delete those. I'll hit change the Y values. And also realize, before I hit graph, let's talk a little bit more about these possibilities. The linear model is a line. It should look like a line. Like that or like this. It should look like a straight line. Exponential, like the one we got, expand. Or it could go down. It could decay. A log graph is much more muted. It looks like a log graph. It looks kind of like this. Kind of like an upside down, or the inverse of an exponential graph, like that. Let's see which one we have here. It's already all saved. I don't have to go back and turn on my stat plot. I saved it already. If I hit graph, I get something like this. And that looks like a log graph to me. It looks kind of like a line, but I think a log graph fits it a lot better. This would be a log graph. B, I would say a logarithmic graph. Okay, and the third one to me a line. We're going to skip that because I don't want to type in more data than I have to. But now that we know how to use a scatter plot, next we have to fit a model to that scatter plot. And there's lots of ways you could do it. Sometimes there's different models that could fit better than the other one. So we're going to do an example here. This right here is the data we just used from the first one. And we're going to use the first one to come up with a couple models. Let me retype the data. I'm going to go back to stat edit. And I have to change my Y values back to the first model. So I typed in the data for model 1. I have a graph, you can see. It's our nice exponential function again. Now, before we figure out the best model, also known as the regression line, let's turn something on most TI-84 calculators that'll help us figure out which one's the best model. I'm going to go to mode here. And toward the bottom, there should be an option that lets you select Stat Diagnostics right here. By default, it's always off. I'm not sure why. I'm going to turn it on. And that's going to help us figure out the best model. How do we figure out the best model? We're going to go back to stat. We're going to calculate. And then we're going to look for a regression that fits. So we have a line regression. Remember, this was not line. This was an exponential. Also, a power function would work. So we're going to look for one of those. So here's an exponential regression line. EXP is for exponential. You hit enter. It says, is your X L1? Yes, it is. Is your Y L2? Yes, it is. Is there a frequency list? That sometimes when you have data, there's a frequency of the second term. We don't have that. We're going to leave it blank. They want us to store the regression equation. So we could put it for like Y1 or Y2. We'll do that. Easiest way to do that if you have a calculator is press alpha F4 and lets you pick any. If you want to put for Y1, Y2, I'll put Y1. This will make more sense in a second. Then we're going to calculate. Now it's going to calculate the regression equation. So it tells you what A and B are. And then what R, these are your correlation coefficients. The closer to 1 your R is, the stronger the correlation. We have a really strong correlation here. And look at what happens if I go to y equals. It put the equation for y1. Hit graph, you're going to see them try to match it up there. This was our power equation, which is, we had our R was like 0.99, and my equation, they gave it to us right now. But see how well that fits the data? Let me go back to quit. I want to see what I typed in, press up. Our equation was, let's see, I'm going to round it a little bit because I don't 0.51, that's our A, and then our B is 1.3, 1.4 if I round it to the X. Okay, that's an exponential equation. Well, if we want to try a different one, I'm going to go stat, I'm going to calculate, I'm going to go all the way down. Again, line regression doesn't work. That's a natural log regression. That's not going to work. A power regression might work. Power regression is a power symbol. It might work down also. Hit that one. Same idea. And we'll also store it in y1. It's going to overlap with the one we did earlier. F alpha, F4, y1, hit enter. Now notice our R here is not as strong. If I did a power function, our R is 0.965, which is still strong, but not as strong as the 0.99 we got last time. Our exponential, what this should have been, is stronger than our power function. And then it gives you all the values. Hit graph so you can see it. And you can see this one does not hit it as well as the last one did. It's not hitting it very well. I'm surprised it's 0.96, honestly. The other one hit it much better. An exponential model fits this data better. Next is real world problem. Fitting model to data. They're giving us minutes and yield. They want for a chemical reaction after X minutes, so how much yield we get, how many minutes. Use the graphing to find a log model and a linear model for the data and identify the coefficient of determination for each model. That's like the R. Which model fits the data better? We're going to go back to here. We're going to type in our data. So I'm going to go stat, edit. We're going to clear these out. Go to L2, put clear, hit enter, then clear, hit enter. I'll type these in off screen. I typed it in, and now we're going to find which model works best. We're going to do the same thing before. We're going to go to stat. We're going to calculate. Actually, let's go to my window. Let me show you. Let's clear this equation. Our plot's still on. When you have our data, you notice you can't see all of it. We could fix the window again if we wanted to. Go to window. My min will be 0. My max would probably be 10. Will still be good. My y though, look at this. It goes all the way up to like 18. Changes to a 20. But there's a shortcut. If we go to zoom, if you go down, zoom 9 is stats. Then try to find a window that fits your data really well. Like that. There's our data. That looks like a logistic graph. Look at the data. That's a log graph. That's not a line. Let's try them though. Let's see what it says. We're going to go over to calculate. We're going to go to our regressions. And the log regression is actually ln. That's our log regression. Hit that one. L1, L2, X, and Y. We're going to keep that in Y1. We're going to see what the graph looks like, how well it hits. And we're going to calculate. And there's our equation. Look at that R, 0.999. Right now I'm thinking the log regression is the best one. Our R is 0.999, 9967. And then if we look at the graph, because we did store it in Y1, look how well that fits the data. That's a really good model for our data there. I'm going to say that's the winner. But just to be diplomatic, let's look at the linear one. That was asked us to do. Same idea. This one, I'm going to store this one in Y2. So you can see the difference actually. Now let's calculate. Calculate for us. We can find the R. R is 0.94, not as strong. The log one's better. If you look at Y equals, look at both graphs on there. Let's see the difference. They always graph in order. So I'm graphing Y1 first. That was our log model. Then they graph the line model right there. You can see the line one's not nearly as good. Which model fits the data better? The log model does. Example 4, fitting an exponential model to the data. The table at the right shows the amount of revenue in billions of dollars, nice, collected by the Internal Revenue Service for selected years from 1963, I think it's supposed to say, to 2008. Use a graphics model data, then use your model to predict the collected revenue in 2013. Okay, first let's type in the data. I'm going to clear all this out, stat, edit. And we're going to go up to the top and put clear. I keep on showing this because it is important to know how to clear the data. And I'm going to enter in all that data. Whoops, let's clear it. And I do it off screen. All the data has been typed in. We're going to go to, so first let's look at our graph. Again, it's not going to fit nicely. You see that? I got to clear those out also. We got to clear those. Those are our graphs. Go to Y equals, clear them out. Now you don't see that at all because look at these numbers. They're really big for what I have down here. So this is one of the ones where the easy ways. This was zoom 9, zoom stat. And it's going to give you, that's our data. And now I would normally say we have to figure out what model fits this best, but we do know it's an exponential model because it says in the problem. So normally you look at it and go, okay, which one does it fit? And you're like, it's growing. It looks more like an exponential. Let's use that. Stat, calculate. We're gonna go to our exponential model right there. L1, L2. Let's make an equation. Alpha F4 and then Y1. Hit calculate. And look at our R, really strong R. There's our equation. Let's see what the question's asking. These models. We want to find the models. There's our models. I'm going to write it down. I'm going to round to the nearest thousandth probably. 1.935 to the 1.076x. So that's our model for the data. Now they want us to use it to approximate 2013. Now there's two ways to do this. So here's our graph. One way, since we have our model, you could just type in 2013 to here. That's one way to do it. You can do this, and then put 2013 up there, and then use your calculator and get an answer. The other way you do it is you do it on your graph. Now, first thing you gotta make sure though is that it goes up to 2013 on your X. I'm gonna go to my window. Oh, it just missed it. 2012. Let's change that to like 2015. I know I have 2013 like in my X. So I'm gonna go like that. I'm gonna graph it. It's take forever to graph. And then what we're gonna do is once it's done graphing, we're gonna go to calculate. It's in blue right here for me. Second. Oh, I'm gonna have to go higher also because I'm not sure if it fits. Like it doesn't go high enough. I think I have to go higher. And let's try it. Calculate, and we're gonna put value. So let's you find a value at any X number. We want to find 2013. It might say error because it doesn't look like it's on the graph. No, it gave us the value. It's way up there. It is 4788.7963. That's the other way to do it. Your calculator. The other way is to use the graph itself. Just make sure it has enough X values. Like if it wants to go 2013, you gotta make sure your graph goes 2013. But that's the estimated amount of revenue collected in billions of dollars in 2013. Okay, one more, and then we're done. Let's talk about a logistic model. That's different than a log model. It's called a logistic model. Example 5, fitting a logistic model to the data. To estimate the amount of defoliation caused by gypsy moths during a given year, a forester counts the number of eggs masses on 1/4 of an acre. In the fall, the percent of defoliation Y next spring is shown in the table below. Whew. Number of egg masses, X, and then percent of defoliation. Use the regression features of the graphing utility to find the logistic model. So we're going to go back to our graph. Let's clear everything out. Let's clear that out. Go to stat edit. We're going to clear all that out. Then we're going to type in the new data and do all this stuff. This data is so small, I'm going to do it in video. We're doing it live. Oops, that's still saying it. That's live. Okay, right here. That's 0, 5, 50. Crap, I have to go back. 50, 75, 100. Okay, this one is 12, 44, 81. I'm saying that more for myself, not for you guys. 96 and 99. Okay, all in there. And then I'm gonna go to zoom 9, zoom stats so I could see it. And that looks like a log graph, but it looks like it doesn't go past this up here. That's gonna be a logistic model. When it has a hard cap on top and a hard cap on the bottom, that's a logistic model. So I want to use that one, especially since that's the name of the example. Use the regression feature. I guess they told us also in the problem. Anyway, let's get out. Go to stat. Go to calculate. Go over here to logistic. It's all the way down here. There we go. L1, L2. I think they want us to store our graph. Alpha F4, Y1, and calculate. Here's our logistic model. Let's copy that down for our answer. For A, we have Y equals. Now notice it's C over. The logistic model is this. It's C over 1 plus AE negative B to the X. We're going to type in our, I can't see. We're going to type in our values right there so you can see them. So it's going to be 99.7. And then we're going to 1 plus A, which is 7.16. E, I'm running it's like the 100th-ish. And then negative B, negative 0.07 X, we'll say that. So that's our regression equation. Now let's see how closely it fits the data versus a graph since we stored it. And right now it looks like it hits that data really, really well. I say it's a really good fit for the model. And that's the lesson.